Okay, kids, so we've done our hypothesis testing, and now we need to talk about what happens when we make a mistake. So there's two different types of error. If we assume that we know the null is true, if that was the actual truth, and we run our hypothesis test and we end up rejecting the null, we call that a type 1 error. If we assume we know the null is true, and we fail to reject the null, that's good. That's not a mistake. If the null is false and we reject the null, that's also good. That's not a mistake. If we know the null is false, the null is actually false in reality, and we run our test and we fail to reject the null, then that is called a type 2 error. Okay? So on your sheet, you have space to copy this definition down. Your type 1 error, you reject the null when it's true. Type 2 error, you fail to reject the null when it's false. You could kind of help you remember a type 1 error. Sometimes we think of it as jumping the gun. And then a type 2 error is a missed opportunity. Another important vocab word that we need to know is power. Power is important. It's the probability that you reject the null when the null is false, which is a good thing. That's over here. That's power. Okay. Some other probabilities that are of interest to us. The probability of making a type 1 error is alpha. Remember, that's linked to our alpha level because that's our rejection region. And then the probability of making a type 2 error is beta. Okay, you're going to want to have that all copied down. So the next three examples, I have a null and an alternative hypothesis, and I want you, in context of the question, to think about what a type 1, type 2 error would be, and then what the power would be in context. So I want you to go ahead and pause the video and see if you could figure out what that would be. Okay, at this point you tried it and now you're ready for the answer. So if your null hypothesis is that someone's innocent, the alternative is that they're guilty. The type 1 error would be the judge finds convincing evidence that the person is guilty when they're actually innocent. So the consequence is an innocent person is found guilty. Whereas if they made a type 2 error, that means we failed to reject the null when actually the alternative was true. So the judge does not find convincing evidence that the person is guilty when that was the case. So basically a guilty person is found innocent. Now, power would be the probability of the judge finding convincing evidence that the person is guilty when they are. So basically, we ran our test and it worked. Okay? I want you to try the next two, and you can unpause once you have it. Okay, so you unpause, so you should be ready. Our null hypothesis is that the person is healthy. The alternative is that they have a disease. So this would be some type of test that we're running. Type 1 error would be we reject the null when it's true. So we find evidence that they have a disease when they're healthy. So it's like the consequence is basically a false positive. We say they're sick when they're actually healthy. Then we could have a type 2 error. So then we fail to reject the null when the alternative is true. So that means the test does not find convincing evidence that a person has a disease when they actually do. So the consequence of that is a false negative. We think they're healthy and they're actually sick. So that would be really bad. And then power, in this case, would be the probability that the test finds evidence that you are sick when you actually are. So the test is doing what it's supposed to do. For the last one, I have some a little more context for you. So you have a potato chip producer, and its main supplier agrees that each shipment of the potatoes must have a certain quality. So the producer determines that if more than 8% of the potatoes in the shipment have blemishes, they're going to send the truck away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. So in order to make the decision, the supervisor will inspect a random sample of potatoes from the shipment. The producer will perform a significance test using these hypotheses. The true proportion is 0.08 for the null. The alternative is that it is greater than 0.08. So for this, a type 1 error would mean that the producer finds convincing evidence that the proportion of potatoes with blemishes is greater than 0.08 when actually it was 0.08 or maybe even less. Now the problem with this is, the potato chip producer sends the truckload away of potatoes that were acceptable, and now they're going to lose money, so you have to wait longer to get the next batch. Type 2 would be the producer does not find convincing evidence that more than 8% of the potatoes in the shipment have blemishes when actually they do. So the consequence of this is that the producer uses a truckload of potatoes to make potato chips, and those were bad potatoes to use. So like the chips that they're using are the chips that they produce, the customers might notice that they're made from blemished potatoes. They might have a lower quality. So they're going to face the consequences of upset customers. In terms of power in this context, that would be the probability that the producer is finding convincing evidence that more than 8% of the potatoes in the shipment have blemishes when they actually do. So we send the truck away when we were supposed to because we didn't want to make chips out of those skunky potatoes, All right. Now, for the very last part of our lesson, I have this picture for you. So this I snipped from your textbook. So I want to just give you some background on the picture. So this is two distributions here. So here I have this centered at P0. Remember, this P0 comes from the proportion that I think is the true proportion from my hypothesis, from my null. Okay? And then this P is the actual true proportion, like if we knew it in real life, what it actually is. And then here, you're going to see this alpha. Remember, that's my probability of making a type 1 error. So this is where I cut off. Okay? And the reason that this would be making an error, because look, here's where the actual true proportion is. Okay? And then I have my type 2 error, which remember the probability of that we call beta. So the first thing that you want to make sure you understand is that power is equal to 1 minus beta. These two things add to 1. Okay? So basically our ability to reject the null hypothesis when it's false plus rejecting the null hypothesis when we were not supposed to adds to 1. Okay, these two add up to 1. Now, what we want to think about is if I was able to actually slide, if I was able to slide this bar over, as we reduce our alpha level, so let's say we were going from like a 5%, the typical alpha level we use is a 5% cutoff, but we could reduce that to a 1% cutoff. As this slides, you want to visualize this alpha is getting smaller. If you reduce that, it will reduce your type 1 error. But then the problem is, as that slides, your type 2 error is going to increase. And anytime you are increasing beta, you're going to lower your power. So, that's not so good because our power is our ability to reject the null when it's false. So that's the first relationship that's important. Now, the next thing I want you to think about is this definition called effect size. Effect size is the difference between the true proportion, so the truth, and what we think is the proportion, so that's this P0 here. So the closer together these are, the more spot on our claim for the true proportion is to this P, then that's going to be a smaller effect size. Okay, so you can imagine these two sliding together. Now, as our effect size increases, so this means this is pulling away from this P, so imagine this pulling out, okay, that's going to decrease our beta, and it's going to increase our power. Now, this should make sense because the further apart these are, the easier it'll be to say, oh, this is definitely really wrong because they're so far apart. Okay? Now, the last thing we need to think about, if we wanted to be able to reduce both type 1 and type 2 error, so I want this and this to get smaller. In order to do that, we really need our distributions to shrink, to get smaller, have less variation. So in order to have less variation, you need to increase your sample size. So when we increase our sample size, that's going to reduce both types of error. When you reduce type 2 error, that increases your power. And I just want to show you guys, I have a little frozen. This allows us to, I'm going to zoom a little bit. Let's see. I just want to show you guys this applet that kind of helps you understand this a little bit more. So remember, our first thing we talked about was the link between type 2 error and power. So here you can see there's my type 2 error, and right now my type 2 error is at 100%. So I'm going to move this a little bit. So here I had my true proportion was at 0.5. The one for my hypothesis test was at 0.68. And you can see here, there is my type 2 error. And then here's my power. So these add up to 1. Okay? Now, as we reduce our alpha level, so this applet allows me to reduce the alpha level, and you can actually see there's the shading of the alpha level. As that gets smaller, you can see my beta is growing and my power is getting smaller. Okay? So you can see, let's see if I can change the zoom one more. Okay, so I'm just going to change my alpha. You can see alpha is getting smaller. My beta is getting bigger and my power is decreasing. Okay, and you can play with this applet and it'll help you understand these relationships between power, alpha, beta, and also you can play with this and it'll change the sample size. As you increase sample size, you're going to see your curves are getting much and much thinner. They're shrinking their variability. And even if, let's see, I'll make this 0.05. So here, if I start with a sample size of 50, you can see my alpha level was 5%, my beta was 14%, and my power was 86. Now we go to 100. And we can go to, okay. So you could play with this a little bit to help you understand it better.